Hey CodeCrew, in the last SwiftUI lesson, you learned about composing complex views using smaller single-purpose views. And you also learned about data flow using state and binding properties. Well, in this video, we're going to take a look at the Slots app that we built, and we're going to see how we can apply these two principles to improve that app. But before we dive in, if this is your first time here, welcome to Code with Chris, where we can teach you how to make an app even if you've never coded before. And you might want to start from the beginning of this SwiftUI series, playlist in the description below. And if you've been following along and watching this SwiftUI series from the beginning, thank you, and please give this video a thumbs up and subscribe if you haven't already. All right, let's dive in. So here we have the SlotsUI app that we built together a couple of lessons ago. And again, if you've missed that lesson, you can definitely check out the playlist in the link in the description below to follow the series from the start. All right, so the first thing we're going to take a look at is what makes sense to break out into its smaller single-purpose view. And what I like to look for is anything that I tend to have to repeat in the UI. So if you've got the same sort of button in a couple of different places, or maybe the same type of image element like we do here, I mean, rather than having this code repeated 3 times like we have right now, we could abstract that card out into its own card view, its own single purpose view, and then create 3 instances of that instead, just like in the last lesson when we talked about the color sliders. So here you can see the code for these 3 cards. We've got these 3 images. They're virtually the same code, except for what icon gets displayed, but we can always use what we learned about data flow, right? Use state properties and bindings and pass that data in. And the other thing that's good about abstracting this into its single view is that, if I wanted to change the look and feel of the cards, you can see this code is repeated 3 times. If I wanted to change the corner radius or the background color a little bit, I'd have to change it 3 times. But if I abstract it out into a single card view and then just use it 3 times, then I only have to change it in one place. So it makes maintenance easier. So let's go ahead and just do that first before we even talk about data flow. So right click here, I'm going to add a new file. And under iOS, or under user interface, we're going to choose SwiftUI view. And I'm going to call this the card view because that kind of makes sense. I'm just going to move this guy up here. And by default, you get that text label saying hello world, but we don't need that. We're going to go into the content view again, and I'm literally just going to copy this guy and I'm going to paste it into here, the body. This piece of data we don't have inside this card view, so I'm just going to hard code an image name for now, just so we can see something on the right hand side. So that's great. This lets me know that this is working, right? And this preview is simply creating an instance of the card view, and that's what we see. So we'll take that and we'll go back here, and I'm going to first remove this one. Let's do a little test, and let's declare a new card view element here. As you can see, that changed. I'm going to do the same thing, removing that middle card, and same for the last one. And that, just like that, we have created a smaller single purpose view, the card view, and we've used it to compose this kind of like bigger, more complex view. Now for this simple SwiftUI Slots app, that is the thing that makes sense to abstract out into its view. If we were to, reuse these other elements in different places, if it were a more complex app, then there's probably more components that I could pull out and make into smaller views. But as it stands now, I think that's all that makes sense. Now we run into the next problem, which is that these card views have a hard-coded Apple icon in the cards. So we need to somehow be able to change those icons. Now the consideration for the data flow comes into play. So who should be the source of truth for these icons here. Just to remind you about how they get displayed, we have an array here called symbols, and there's apple, star, and cherry. These represent the possible icon choices or the image names. And we have another array called numbers, which indicates which icon that card slot should be. So this first index of the numbers array represents this card, the middle one represents that card, and the last index represents that card. So depending on what number this is, it's going to kind of result in a different icon here. Remember in the last lesson we talked about source of truth, the state properties. So we definitely do not want to keep a copy of the numbers here in the content view and keep a copy of what individual index this card is also in the card view, because that would be duplicating the data, right? And so it makes sense for me that the content view should be the source of truth, and that it should be passing the bindings to these numbers to the card views itself. Because number one, the content view has the logic to check for matches, right? After they hit the spin button, we have some code right here just to check if the numbers, if this one matches this one and if this one matches this one. If we made the card view instead kind of hold its own number, right? If we had a state here and we said, we made it hold its own number, it would make it harder for us to be able to match, to see if this card matches the others. So that's why, at least my thinking is that right here, the content view should be the source of truth of this data, and instead we should pass the bindings into the card views. So that's what I'm going to try to do here. Let's hop into our card view and take a look at what we can do. So this is the hard-coded string that represents the image. So I'm going to create a binding for it so that it can be passed into the card view when it gets created, instead of having a hard-coded string there. So I'm going to say binding. We're going to say, let's just call it symbol. And it's going to be of type string. I'm not going to set it to anything because I want it to be passed in. And then here, instead of hard coding the string, I'm just going to put symbol. And now this preview is broken because you can see here, you can't just create a card view element and expect it to be displayed, because it needs to know which symbol to display, right? And it is expecting a binding to be passed in. So if you just get rid of those parentheses or brackets, you can see that you're supposed to pass in a string type binding. So unfortunately, we don't have any real binding to pass in to this preview right here. But what we can do is pass in a temporary binding value to just for the purpose of the preview so that it can display something. So the way you do that is you go binding dot constant, and then you can specify a value. So it's got to be a string. So let's do cherry. So then it's still going to allow you to pass this in as a parameter, but it's not a real binding. It's just a constant value. So unfortunately, it's not building right now. Let's just take a look at why here. Card view type is not convertible. Yeah, so back in the content view, all of these are broken now as well. So why don't I just do the same thing, just so we can just do one thing at a time. So let me just show you that this works and that we can actually see something before we actually use real bindings. Yes. Okay, so there is the parameter label right there. Okay, so if we go back to the card view now and we try to update the preview, you can see that we see cherry because that's what we put right here. All right, now let's go back to the content view and take a look at how we're going to pass in the bindings for the symbols. Right, so up here, my numbers, this is already a state property. I'm going to change this to a state property as well. Now I'm going to go down, and instead of passing in a binding constant for cherry right here, I can pass in a real binding from the state properties up there that we declared up there. So we have symbols, and then inside here I think I called it number, right? So this would be 0. All right, let's just see if that is okay before I do anything. Oh, numbers. Okay, so it would help if I could remember my property names. All right, so we're going to do the same thing here as well. Numbers 1, and this would be symbols numbers 2. Okay, so let's resume. Build succeeded, and you can see that this reflects the indexes that we have right here in numbers. And if I build and run this, did I forget anything? Let's take a look. All right, so you can see everything is working perfectly here. And we've successfully abstracted the card view into its own single purpose smaller view. And we've facilitated the data flow where the content view is the source of truth for the symbols and what indexes those cards should be. And then passing that into the card view element as a binding. All right, now I want to solve another issue here, which is that it's really hard to detect when there is a match like we just had. You can't even see it unless you notice your credits going up, but at the same time they're going down, so it's always changing, and it's just really hard to tell when you get a match. And so what I'd like to do is change the backgrounds to green when there is a match. And this is going to give us another opportunity to practice using state properties and bindings. So I'm going to create a state property up here for the 3 background colors for the cards, just like we have here that represents, you know, which icons they are. And then we're going to pass that as a binding into the card view here and have the background change when there is a match. All right, so first let's declare a new state property here. I'm going to call it backgrounds. So I'm going to default them to all white in all 3 slots. And then let's go into the card view and add a binding. So instead of just using white by default, we're going to have that value as a binding. And this is going to be of type color. And again, I'm not going to assign anything to it here so that we are going to be forced to pass it in when we create the card view element. And don't forget, instead of hard coding white, we're going to use the binding. All right, so here this preview is broken because now we have to pass in an extra binding. So let's go ahead and just hit fix. So it adds that label for us, and then we're going to do a binding constant. Well, this is going to be a color. So let's just say green. We'll save it, and I'm pretty sure this preview is actually broken. Yeah, because the project is broken right now. Don't forget, we just added another binding, and inside content view, we create these 3 cards. These are not valid instantiations of card view anymore. So it expects another binding to be passed in. All right, so let's add that parameter here, and we're going to pass in the background color. So backgrounds 0, right? This is a binding for the state property that we have up here. So that's where that's coming from. And we're going to do the same thing with the second card view. Let's have that parameter, and then backgrounds 1 this time. Backgrounds 2. Okay, so now everything's set up. If we run the project now, it's going to be fine. But however, the backgrounds aren't going to change because we actually don't have any code to update the background's state property. So we have to update that when there is a match. And we have to, don't forget, we have to set it back to white when the user spins again. So right here, they won. So we're going to update the state property, update backgrounds to green. So we're going to say self.backgrounds equals color green. And we're going to do this for all three. And I'm going to show you another way of writing these three statements using a map function just in a second. But let me just do it this way first. That might be something you do know or something you don't know, but it'll be helpful. Set backgrounds back to white here, because this is where the user hits the spin button before we actually spin anything. All right, so we have when the user taps on the button, we set it to white, and then if there is a match, we update it to green. So let's run this project and watch our code take effect. So it's white. Did you see that? There we go. So that's pretty cool. So now let's talk about that map function I mentioned. So the map function is something that you can do with arrays when you want to do something with every single element of the array. And it's a more concise way of writing it rather than repeating yourself 3 times like this. And imagine if we had even more backgrounds, like 9 backgrounds or something like that, then this would be 9 lines of code. So here is just another way to write this in case you don't know about the map function. And I don't think I've really ever taught it in any of my other videos just yet. So here's how it goes. So it is a function that you can use with an array. So you go .map, right? And you pass in a closure. And this is the code that you want to run on every single element of your array. So you can see that there is, this is the element, this parameter here represents the element that is currently in that array slot, or, this is the element that you're transforming. Because we don't want to transform the color white, like we're not going to do anything with that color. Instead, we want to replace it, right? We want to assign something new into that slot. So we actually don't need this parameter. So we're just going to replace this with an underscore. And as for the code, we simply write color.white. And that is essentially going to replace whatever was there. And look, the result of the call to map is unused because this function basically returns a new copy of your array. It doesn't modify your old one. So what we're going to do is we're going to assign it back to self.backgrounds. Let me just create a little more space here. There we go. And so this, although it's still 3 lines, is a little more concise than writing this, a little more elegant. But I do want you to keep in mind that this is perfectly fine. And this really comes in handy when you have many elements in an array. So I'm just going to show you what it would look like if we did it like this, right? You could do this with the color green down here. And then if you're really observant, you can also notice that we are running the same operation on every single element in the numbers array as well. So we can use map here. So self.numbers equals self.numbers.map. Right, let's open up that closure. Again, it's going to give me the integer currently, which is the element in that slot. We don't need it, so we're going to put underscore because we are assigning, and we're just going to run this code right here. And it's basically going to run this code for every element in the array and assign it to that slot. So get rid of this, and that's an even bigger savings, right? Like that made the code a lot more concise. But the thing is, For a lot of the beginners who are watching this, I don't want to start doing this too much because it's kind of hard to know what's going on if you are just starting out. And my primary focus is making sure that you understand the code and you can follow along in terms of the logic and understanding. And so, you know, if it's a lot of extra work, like if there were 9 elements and I'm doing the same thing to every element, then maybe I'll just mention and use the map again. But for this, I'm simply gonna do it the simplified, not so concise way. Just so anybody who is reading this, no matter kind of what the level, even if you're just starting out, can easily understand what we're doing. However, now you know that this map function exists, you can add it as a tool to your arsenal for your Swift development. Yeah, our Slots app is progressing really nicely. And if you're up for it, I actually have a challenge for you. Can you add 2 more rows, one to the top and one to the bottom, for a total of 9 cards, and make it so that matches can occur horizontally on all 3 rows and also diagonally? And for extra bonus points, can you add a second spin button so that the user can either tap one of them that only checks the middle row for matches, and the second button, which costs 5 times as more credits or whatever amount you want, but that second button checks for matches on all 3 rows plus the diagonals. So it's going to cost more, it's higher risk, but higher reward. Oh, and I forgot one quick tip for the challenge that is actually quite crucial. So in any of these containers, like a Z stack or Z stack, V stack or H stack, any of these containers, they can only contain a maximum of 10 elements inside. But don't worry, you can nest it. So let me just give you a quick example. Inside of this V stack, we have spacer, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, and that's 9. So inside this V stack, we have 9 elements already. So you can put one more element, and that would be 10, and that would be completely okay. But if you try and put an 11th element, you're gonna see an error. And the thing is, the error message isn't very helpful because it's just gonna point to something else. At least in this example, it's not actually telling you what the real problem is, and that is that our V stack has 11 elements. So how do you combat this? Well, you can, let's say this is one solution. You can nest these 2 elements inside of their own V stack. And although in this example it kind of changes the way things look, but that's just to get your thinking going. So just keep in mind that there is a 10 element limit per layout container, and that if you encounter a SwiftUI error and your preview won't work and you can't build your project and the error message doesn't really make sense, just remember that you can double check that, and as a solution you can nest these things together. Share a screenshot of your completed challenge with me on social media and make sure to tag me so I can see it. And if you also want to earn a special forum badge for your achievement, make sure you post your screenshot in my CodeCrew forum under this topic. I'll link to that forum thread in the description below. And if you need help with this challenge, the CodeCrew forum is going to be the place to go to get help from myself, the team, and other developers just like yourself. And as for the solution video, I'm going to give you some time to try out this challenge for yourself first. And then when I release that solution video, I'll remember to make sure to put a link to it in the description below. All right, thanks for watching, and I'll see you in the next lesson.